and knowledgeable today, exploring the depth of deep learning. Thank you. Thank you once again. Welcome, ma'am.
Welcome.
Yes, ma'am.
Yes, ma'am. Yes, good evening, everyone. Welcome you all for the second day of workshop Think Deep, Learn Deep, hands-on deep learning workshop. And in continuation with the last day workshop, and we have seen the artificial neural networks, types of artificial neural networks like feed-forward neural network. And in continuation with, we will see the convolutional neural networks. As we discussed the feed-forward neural networks yesterday, and both the convolutional as well as the feed-forward neural networks are the types of artificial neural networks, and both can be used in any machine learning models or in deep learning models. So both are specifically designed for processing the data. Suppose in the CNN, we have to process the data look like the grid structure, such as images. The images has been converted into the grid-like structure, and if we have the feed forward neural network, that can also be used for variety of the task. Okay, so the cnn's we can cnn's use a convolutional layers that we can call it as a convolute to extract the features from the input data. So, but in FNN, it can pass simply the data through the series of hidden layers. In FNN, we can have three layers: input layers, hidden layers, and output layers. But in this FNN, we can also additionally we have the set of layers we used, and we can have a series of hidden layers. And CNN, when comparatively, it can have more complex, and it can more intensive than feed forward neural network, and but it can more effective for doing the task of such as for image recognition or object detection or any kind of application. So it is designed for, mainly it is designed for image processing task. It will accept it accept the input of fixed size, but in feed forward neural network, it can accept any kind of size, and it can have a convolutional pooling as well as it can have fully connected layers. And we can have the feature extraction in this. It can perform manually in this feed forward, but we can have automatically in convolutional neural networks. So both can be used with the same architecture, but it is designed for grid-like data as like images. It can have multiple layers, including convolutional layers, pooling layers, fully connected layers. And the convolutional layers, generally we can apply the filters to the input data to extract the features. And if we have the pooling layers, which can reduce the dimensions or size of the data, so it can be here we can, each neuron in a layer is connected to every neuron in the subsequent layer, then make it as a fully connected network. So both the convolutional and feed forward neural networks are powerful tools which must be used in the machine learning, and they can have a distinct attributes, make it as useful for different applications. So that is why that is the difference we have in CNN and FNN. And followed by, we can see the key components of CNN, and we must able to know what is convolutional and what about the feature extraction, how the features can be extracted through this model, and what are all the types of CNN, and what kind of what will be how the CNN behind the concept of dropout and batch normalization, and how the overfitting and regularization process must be done in the CNN, and followed by the advantages, disadvantages, applications we can have the image processing applications. This is the roadmap of today's session. And next one is, what is convolutional neural network? So in this convolutional neural network, we can primarily, it can be designed to extract the features. and it can have a, huge data set, that is visual data sets like images or videos. And here we can have a data pattern that can used majorly here. And because we can use a computer vision applications, and it can be used effectively to process the visual data as well. And the convolutional neural networks are the neural networks that can share their parameters. So it can convolution. Imagine you have an image, so it can be represented as a cuboid shape. In normally the cuboid, which can have a length, width, and height, it must be represented as the dimension of the image, or the height. The height, the images generally that must have represented in the red RGB colors. Okay, so now imagine we can take it as a small patch of images that can run with the network. It can be called as filter or kernel. So we say that we can use it as k outputs representing them vertically. So we have to create a neural network across the whole image. As a result, we will get another image with a different width or different height or different depth. So we have, instead of RGB colors, now we can have more colors but lesser width and height. So the entire operation is called as convolution. So if the patch size is same as that of the image, it will be a regular neural network. So if we have to modify, or if we have to done something, then we can have a newer weight or newer patch or newer head width and so on. So that is, we can do the process of convolution. So in this convolutional neural network architecture, that can have a set of layers. And here in this network also, how the data flows from input to the output. It can pass through a set of layers: input layers, convolutional layers, pooling layers, fully connected layers, and output layer. Finally, we can, if you have the input as image data which contains, for example, 28 pixels, and provides a final result as a classification of finding an image, whether it is an apple, or whether it is used to identify the images of cat or dog and so on. So here we can, in this convolutional neural network is made up of several blocks, several components. So here we have the layers. Along with the layers, we can have the components, and the components will work together to access the feature extraction as well as the decision making. So here we have the two concepts we in this key features. One is the convolution, and the second one is the key feature extraction that must be used here. And in this convolution, you can have a filter slide. It can have a filter side that can move over the image matrix, because it could be represented as a pixel image in terms of matrix. So it multiplies the pixel values and add them up to produce a feature map. And we can have a different filters we can use for different features, and like edges, or corners or textures, whatever. So based on that features, we can apply different filters. And finally, we have the second one is feature extraction. So in this feature extraction, we can detect the low level features or the patterns, or we can able to detect the high level features like face or objects, anything. So these two concepts will be used in this convolutional neural network. And apart from that, we can have a types of CNN, and we will see the dropout and batch normalization process, like regularization techniques, which can also used to improve the CNN performance. And the normalization, which can be used to activate the features between the layers. So it can be used to reduce the dependency between the layers. So that is why we use to normalization. and we can have overfitting regularization methods. So wherever we have to use a overfitting, it can perform well while we are training the data. While we are training the data with an unseen data. We have to train the data poorly while on new or unseen data. And the regularization technique, which can also be used to that is, you have to prevent overfitting, that can also be used. So these are all the techniques we will see in this convolutional neural network, and these are all the general features used in the convolutional neural networks. And apart from that, we can have the applications where it can be used nowadays. In the sense, we can use it in the healthcare applications. It can also be used to in security applications for recognizing the face or surveillance, or it can also be used in the agriculture field, like crop disease classification or pest classification, or it can also be used in the robotics, as well as in the education purpose. We can able to identify the handwritten text or character recognition. So these kind of application that can be used on it is purely based upon the images and videos. For example, if we have the videos, we can able to upload the data set as a kind of reviews of a particular video. We can able to find or predict the review of a particular movie. So it is mainly used for visualization of AI systems. So it can be used in the image analysis. So it can able to use segmentation, object detection, and image generation and image enhancement techniques. So these are all the applications of convolutional neural network. Now we can see the structure of convolutional neural networks, which can be related to the human visual system. So it is automatically CNN, which can be used automatically and efficiently recognize the patterns. And we can also add the special features, and which can be treated as an inputs equally. So it can, but in this CNN, we can also use the pixels in an image that can be related, that can be used as a matrix. So it can be, the group of pixels can be represented as an edge. So several edges can create a form. So here we can have such kind of components. And in this convolutional neural network, I said we have a set of layers: output layer, dense layer, pooling, convolutional layer, and the input layers. And this is the way it is related with the human visual system. And the next one is, what are all the key components that we have seen in this architecture? So input layer. So it should be it should be the structure of architecture of the convolutional neural networks. So, and here we have the components. So here we have the components: input layer, and convolutional layer, activation functions, pooling layer, fully connected layer, and the output layer. So if we have the output layer, it can be from the fully connected layer. It can, the output from the fully connected layer that can feed into the output layer. It can take it as the logical function for the classification of tasks, such as sigmoid function or softmax function, which can convert the output of each class into the probability of each class. The fully connected layer, it can take the input from the previous layer, and it computes the final classification or the regression task. And we can have the flattening layer. So it can have the one dimensional vector after the convolution, as well as the pooling layer, and it can be processed into a next layer, and it could be the categorization or regression. And here we have the convolution through this convolution layer, and we can also able to perform a ReLU activation function here. So these are all the components, and these are all the building blocks of the convolutional layer. So in this convolutional layer, we can have the several filters of equal size. each filter that can be used to recognize a particular pattern of an particular pattern from an image. Suppose, for example, curving of the digits. So we have to recognize the handwritten character. So we can, for in that it can have the curve of the digits, or we can have the example of edges, or the whole shape of whole shape of the digits. So these are all the input that must be feed into the in convolutional layer. So we can, in this convolutional layer, it can have a small grids that can make over the image. So based upon that, it can create such kind of matrix like a 3 cross 3 and so on. So each grid is like a glass that look like a specific pattern in the photo or in the line or in the curve or in the shape, any kind of shape. So as it moves across the photo, it creates a new grid. So we can able to draw an handwritten image over the grid structure. So it creates a new grid that will found based upon the pattern. So one filter that might be, for example, good at finding the straight lines. Another one is it can be used to find the curves. So we can use several filters that make up several filters that make up on different patterns to frame a image. So through this we can able to use this. And the next one is, and we can have the input image that can be in the grayscale image. So grayscale image of 28 into 28, for example, 28 28 into 1. So here each pixel that can have the value of 0 to 20, 0 to 255, it will represent how it will be dark or how it will be light. The last one is represented, that is, it can be represented as the number of channels. So here by usually we have to use one as the number of channel. We can also able to use the multiple layers. Here we can also use it as three, in the sense we have three channels like RGB. So an image of the digit 5 looks like the matrix of numbers, or 6 we can also able to represent 6. And the next one is convolutional layer. The convolutional layers which is used to filter the filtration of the edges, deducting edges. So we can have a small filters, and which can able to filter the detects or the vertical lines or the horizontal edges or any curve or any corner. So here each and every filter that can perform the convolution operation, so multiplying its values with the pixels, and it overlaps with the summing up of them. So it will create the convolutional layer, which will create a feature map that could be the output image highlighting within features. And the next one is we have an output layer, that is output shape. Suppose we have an example of 32 filters, 28 28 into one image. You can able to get 32 feature maps of edges. So in that you can be able to create 28 28 into 32. So here we have to use 32 features. And we can use the ReLU functions. ReLU function, which can be used in the non-linearity. So after the convolution function, we can apply the activation function, that is rectified linear unit, which keeps the positive values, as we discussed already in the last class itself. It keeps positive values the same and replaces the negative values as 0. And if we have, it will makes the model to be faster and avoids a vanishing gradient process. So that is why we used a ReLU activation function. And the next one is a pooling layer. It will pooling layer, which will be used to reduces the size or dimension. It reduces the size of feature map while we are using in the convolutional layer. And the next one is we can also able to use the maximum, not only min polling as well as max polling we can use. Max polling, we can take the maximum value in the small region. Min polling, we can take the minimum value in the small region. So it can have for example, it can have a 2 cross 2 window size. It can across the feature map and it keeps the largest value, and it will keep the largest value of polling into that is 2 into 4, 14, that is 24, I mean 2 into 14, 28 into 28. So it will makes the network as smaller as well as the faster, and it can also able to prevent the overfitting. So it will ensure that the features such as edges or corners that will remain the same. And we can also have the second convolutional layer also. In the second convolutional layer, that can, it will work on the first layer's output. First layer's output that can have a feature map that will not in the raw image. So it will filters more complex patterns like circles or digit curves or any specific number shape. Suppose if you have represented the number within the double quotation, or it can learn the edges. Second layer, first layer, we can it can learn edges. Second layer, it can shape made up of the images, made up of the edges. And after that, we can have a flattened layer. In that flattened layer, we can convert the 2D feature image map into 1D vector. It can have a list of numbers. So it can have a list of numbers. You have to convert into the 2D into 1D vector of length. So you have to multiply all these things and convert it into the value. Suppose we have an example of 7 into 64 features. So in that you have to convert it into convert it into vector in the sense probably 3000. So in this flattened layer, it will bridges the convolutional part into the fully connected part. And the fully connected part here is a dense layer, which is used for the classification, just like we have an FNN. So here each neuron connects to all the neurons from the previous layer. So these layers combine the extracted features to make the final decision. So in this fully connected layer only, we can able to make a decision. So in this dense, fully connected layer or the dense layer, which can have a ReLU function, it can learn the combination of features like round or vertical line. For example, round or vertical line for an image line. Okay, so finally we can have the digits. For example, digits, it can have 10 neurons for 10 digits, and it can give the predicted class. For example, we have used MNIST data set for identification of digits, handwritten images. So, and in this we can also use we can this 3NN model, through this model also we can able to predict or identify the character recognition. And this is the key components, and these are all the components layer that must be used in this convolutional neural network. And the next one is, so this is the architecture we discussed: the input layer, convolutional pooling layer, and fully connected layers and output layers. So here we have the convolution process that must be taken. It can have a small matrix called a filter or a kernel. It can move or over an image and perform the dot products, and a dot products part of through with and part of an image, and it will also detect patterns on different areas of image like vertical edges, horizontal lines, corners, or any textures. So suppose we have an image of 28 cross 28 pixels, you can use 3 cross 3 filters, which moves across the image one step at a time. Each position, the filter multiplies it 9. So 9 threes are 27. So multiplies by 9 values with the 9 pixels it covers, and finally it will sum up. So one pixel in the output it as a feature map. So if you want to filter look like a vertical edges, it will give high values, There is a strong vertical line we have with the low values, and each filter it will create a feature map and showing that finally where it will be the pattern appears. And the next one is the concept of convolution and feature extraction. So, as we discussed already, what is convolutional operation? And it is a mathematical operation which in which a small filter it can be as a kernel, it can be slides over an image, and we can also able to use a multiple filters to learn different visual features. And in this feature extraction process, we have the layers: first convolutional layer, deeper layer, pooling layer, and flattened and dense layers. So here in this feature extraction process we used. So why we have used in this feature extraction process, it will automatically extract the features from raw images. So in this first convolutional layers, it will detect the basic features like edges, lines, or gradients, textures. So the output of this first convolutional layer, it will map the features and highlighting those features of these. And the deeper convolutional layers, it will combine the earlier features to detect a complex shape like a circle, eyes or digits or objects. So we have the first layer detect the edges, and the second layer it will detect the corners or curves, or it can be a combination of any edges or the curves. And the third layer it will detect the object like a nose or the number 3, for example. And the next one is the pooling layer. It will reduce the size of feature maps. So we told the 28 size has been reduced into 14. So it will makes the computation. Why we have reduced the dimensionality? It will yeah, it can perform it faster, and it help the network to focus on the key information of mostly important features. And we can have a max pooling. It will keep the strongest signal in each small region. So we have to find the max value in this maximum value. And flattened and dense layers which are used for after extraction. So we have the CNNs flatten the 2D images into 1D vectors. So we can go fully connected layers or dense layers. It will combine the features to make a final decision whether it may be to identify the image should be a cat, or it should be identify the digit should be set. So for that we can use these features, convolution and feature extraction. And here you can see the types of CNN. In this type of CNN, we can have the set of types of CNN, that is convolutional net. Normally, we used a convolutional neural network that can be called as ConvNet, and sorry, LeanNet, which can be used for the digit recognition. We can use MNIST, and it can also have the convolutional pooling fully connected layer, and which is used for recognizing handwritten images. And third one is AlexNet. So AlexNet, which can be used for image classification, ImageNet competition, which can have 5 convolutional layers and three fully connected layers. And the next one is Google Net, or we have the inception of V2, I mean V3, V4, V so on. And Google Net, we have V1. So in this Google Net, it can be introduced the inception module. It can allow the multiple convolutional filters to that can be run in the parallel, and it would be very efficient one comparatively. And ResNet, that is a residual network, and which can be introduced for residual connections, which can used to allow very deep networks without vanishing gradient issues. So and which can be used as revolutionized deep learning techniques. And the next one is followed by the dense net. It's a densely connected network. Each layer it can in this net, each layer receives the input from all previous layers, and the output is passed to the subsequent layers. And the next one is res next and resnet, both are used in this same concern. And last one is channel boosted CNN. and efficient net. Channel boosted CNN, we can also able to add the extra feature channels, and the extra feature extraction techniques must be used, and which can also be able to enhance the performance, or enhance the performance for imbalanced data sets, for example. And the last one is efficient net, which can be used as depth-wise separable convolutions. And it can also be more efficient and powerful than the V1, V2, and so on. And these are all the types of CNN. And now we have the example of the image analysis in the CNN. So let us consider we have an example of 3232 size of grayscale image of a handwritten digit. And let us consider the kernel which is used for the convolution. It's a matrix with the dimension of 6 cross 6 we have. So in this weights of each element of the kernel is represented in the grid. So zero weights are represented in the black black grids, and the other one we can have the values that can be used in that can be ones in the white grid. So why do we have manually find these weights? So in real life, the weights of the kernel are determined during the training process of the neural network. So using these two matrices, we can perform the convolution operation by applying the dot product. So we can apply the kernel matrix from the top left corner to the right. And we have to perform the element wise multiplication, and finally we have to add the values of the products. So the resulting value that will be corresponds to the top left corner in the convoluted matrix. So we have to move on this and respect to the size of the window. So until we have to do the same steps to create the convoluted matrix. So the convoluted matrix, it depends upon the size of the sliding window. So it will be based upon the higher value or smaller the dimensions. And the next one is we have feature extraction. So feature extraction, in this we have to take it as the feature detector weights, and it can be used to detect the specific features in the input image. So if we have averaging the values, averaging the kernel pixel values, it can be used to blur the input image. So it will be subtracting the neighboring kernel, which is used to perform the edge detection. So we have to use a more convolutional layers. It can, based upon the more convolutional layers, it can use to give a better result to detect detect the images clearly. And the next one is we can have the application of max pooling with the filter. So we have a activation function we have used for each convolution operation. So in this, which is used to the activation function, which is used to help the network to learn nonlinear relationship between the features of an image. So in this pooling layer, we can use max pooling layer. So the pooling layer, we have to pull the most significant features from the convoluted matrix, and we can have the aggregation operations. The aggregated value can be produced in this convoluted matrix. So it will be reducing the memory while training the network. So the spooling mainly used for mitigating the overfitting process. So we have in this max pooling and sum pooling and average pooling that could be used in this pooling result. So max pooling, which is which is the maximum value of the feature map, and sum pooling, which is sum of all the values in the feature map, average pooling, which is the average of all the values. So these aggregation function that can be done in this max pooling process. And in this pooling, after this pooling, we can have overfitting. We can able to check overfitting and underfitting, which is done in this fully connected layers. So these layers in the convolutional neural network, and it can take their input and corresponds to the flattened one-dimensional array matrix and generated by the last pooling layers. And finally, we have to apply the relay activation functions, and relay activation function or softmax through a prediction layer, which is used to generate the probability values for each of the possible input values. So the final one, which has the highest probability score, we have to take it as. So in this overfitting and regularization techniques, so we have overfitting that could be the common challenge in this machine learning model as well as the CNN. So it happens whenever the model learns the training data, which must be uh, learning through heart. Suppose it includes its noise or outliers. So the learning leads to become a model that performs well in the training data. So for that we can use. So overfitting occurs whenever the CNN learns the training data too well. And instead of learning the general patterns, it can apply unseen data. So why overfitting happens in the CNN? So we can have millions of parameters. So if the data set is small or not, diverse through. So the model can learn the specific image background, or it can become the biased toward training samples, or it can lose generalization ability on unseen images. So the regularization techniques, which can penalize over complex models, and it can also able to add constraints to help the CNN generalize better. So for that we can use generalization. And finally we have the 7 strategies to mitigate the overfitting in the CNN. So we have the dropout layers, so dropout mechanisms that randomly dropping the neurons during the training process, while forces the remaining neurons to learn new features from the input data. And we can also use as the pooling layers in this dropout. It will reduce the dimensions of the input image. And formally, and we can have the data augmentation, and data augmentation which can increases the data set size by applying the transformations like any rotations or flipping or cropping, any transformation that must be done in this data augmentation process, and which can also increases the size and diversity of training data set. And we can have a regularization method also, a regularization that is L1 L2 normalizations. In this we can add a penalty of large weight in the loss function. And here the both L1 L2 normalizations, that can be used to add a penalty of the loss function based on the size of weights. And we can have early stopping. So early stopping, it can stop training when validation loss, and stops improving whenever the model starts. So it automatically stops training at the right time, or it will prevent the overfitting. And the next one is we can also use consistently monitoring the model's performance and validation data during the training process. And we can have a batch normalization. So in this normalization, we can normalize the activations between the layers, or for speeding up the process. And we can have a batch normalization as well. So a batch normalization, by normalizing the input layer by adjusting with activation. So it can also used to speed up and stabilize the learning process. So these are all the 7 strategies we used in this. And next one is we can have the advantages and disadvantages of CNN. We can use the CNN models. We can use in this identifying patterns, images, videos, and so on. But it can require large amounts of data, and that could be the drawback of CNN. And followed by the applications. These are all the applications of used in this. CNN. So it can able to recognize the face, or it can be used to diagnose the patient whether the person infected by liver disease or not. And video analysis, through this video analysis we can able to find the review of a particular movie, and we can able to find out the image generation. So image generation, and it should be compressed one. And it can be able to used in NLP techniques, able to detect the text and object detection. It can able to detect the object of a particular image, whether it can be comes under the cat or image, and the image classification. So these are all the applications of CNN. Now let us see the uh, demo part of how the convolutional neural networks that can be. So in this, we will see the example of how the convolutional neural network has been model has been implemented. So we can in this we use a PyTorch. So before that we must ensure whether the PyTorch library has been installed in our system or not. Why we have the PyTorch? So in this we can use in this we can able to create a convolutional neural network, and it can also be used for fast training of the data like nvidia gpu, and it can also be used for uh, path propagation, so computing the path propagation gradient boost, and can also used to debug easily. So for that we can use pytouch one. So first one is we must know what are all the steps to be followed for the implementation of a neural network. So first one is we have to load the data set. If it is kindly ensure if the data set has been loaded into your path or not, and make the data set iterable one. It can be converted the large data set into a smaller data set based upon the convenience one. After that, we can create our neural network model, and we can instantiate the model by creating the class, and we have to instantiate the last class and instantiate the optimizer class, and finally train the model, compile the model, and test the model. So in this model we can have two convolutional layers and two max pooling layers and one fully connected layers we have used. So here this first one is you can check whether the file has been whether the library has been imported successfully or not. And the next one is we can have the data set. So here we can upload the data set, MNIST data set, the size of and the size of training data set. So we must ensure that you have uh, loaded or not. And in this next step, after that, we must give our size of training data set model. So here we have to know the size of data set model, which contains 60,000 images, and we can able to know the size of testing data set, and we can able to categorize the data set into 28, 28. And next one is we can also able to size we can able to set the size of testing data set, and which can be out of 60,000 we can able to test the data set over the 60,000 is 10,000 we can use. And here we have to use a label size and size which will be used to the size of data set, and here we can use the tested data set with the size of 10,000. And next one is make the data set iterable, and it can be used to reduce the size. So here we have data set. So you have to import all the you have to import the training data set, and we have declared the batch size, and you have to use the shuffle method, and shuffle method is true, and we can also able to use the number of patches based upon the number of iteration divided by the number of training data set. So and then we can use we have to check whether the data set iterable or not. So through this calling of this method, so calling of this variable, it can be iterable one. And now we have to create a model set. So now we have to define a CNN model here, CNN model class, and in that you can use a convolution 2D, so 2D matrix, and which has the input channel 1 and the output channel is 16. It will create the 16 filter, so the output will have a 16 feature maps, and we can have the kernel size 5, and each filter is 5 cross 5. So for that we can use, and stride which is equal to what, each filter is 5 cross 5, and padding length which will be adds zeros around the edges, and it will be keep the output size which has same as the input size. And we have used a ReLU function here, so it can have in this layer we can have 16 different low level features like edges or corners from the image. And after that we can create a max pool layer 1, and it can feature the map of maximum value. So max pool 2D which can have the maximum value in the 2 cross 2 region, and it will also used to reduce the size by half. And it will why we reduce the size by half, and it will be used for computation and overfitting. And the next one is we can have a convolution layer too. It will take the input from the 16 feature maps where we have set already. So 16 feature maps of the previous layer, and which will produce the 32 feature maps. It will detect a higher level patterns like a shape or textures, anything. And after that, we can create the max pool layer. So max pool layer 2, again in this max pool layer, it will reduce the spatial size by half. Already we have half, and again after that, it will be reduced the half. So it will be keep track of all the important features, and it will discard the relevant information. And the next one is fully connected layer. It can have two rounds of pooling. So the feature maps, it will shrink the size. If we have a 2828 MNIST data set, and first pooling, it can be 28 into 20 converted into 1414, and second pooling of it will be reduced the half, 1414 into 77. So for that we can use. So in this 32 feature map, we can have 32 into 77. So 77, it approximately 1500. So these features that can be fed into the fully connected layer with 10 output neurons. So initially we have 16 output layers. So 10 output layer neurons that can be used for 10 classes that can be recognized 0 to 9. And we have the function that is forward pass. So in this forward pass, we can have a convolution layer and convolution 2, and convolution, that is first one is convolution layer 1 max pool, and convolution 2, and it will produce us the final class score, and the final output um, which will be 10 values. So which will be 10 values per image. So it will representing the scores. So suppose for example in this convolution layer, we can 100 neurons, 100, 16, 28, 28, 16 filters were used. And the pool one, we can have 100. The 28 has been 14. So 16 neurons, 14, 14. And the convolution 2, we have 100 and 16, 32, and it can be 12, 12. After pool 2 only, we can reduce the half by 100, 32, 77. And the flattened, through this flattened range layers, we can 100 into 32 into 77, and that can be converted 1500. It can be converted into 1D. And finally we have the output digits, that is 100 by 10, 10. So it will be 10 classes. So 10 classes which is used to recognize the images of a 0 to 9. And the next one is we can instantiate, after the creation we can instantiate a model. Just you can call the object of a model. And next step is you have to find the entropy loss and create an optimizer class and create the model parameters, and we discuss the size of each and every model after the creation of model. So finally it could be the size of 10. So here we have the calculation. So 1632 and 30 and 1568 after multiplying this, and finally we can have the size of 10 to recognize the patterns. So after that you just train the model. It will be working. And suppose for example if we have to test on a single image, it will be used to predicted image. It could be look like this. And the second example is second application is we can also able to use two convolutional layer, two average pool, and one flattened convolutional layer with the same size. Okay, with the same size, and what will be the model after using the convolutional layer, and which will also uses which will also used to build the model, and which will produce the iterations and loss accuracy level of with the same input size. And this is the way we have to build our CNN model and application. So we can able to classify the images whether it can be dog or cat. For that we can use CFIR 10 data set. So we have to load and pre-process the data. And next one is And we can normalize the pixel values between 0 to 1 by dividing the categories of 0 to 255. And the next one is you have to categorize the data and for encoding. And we have to build the DCNN model is through sequential layer. It could be a linear way. And we can create the three convolution layer here and flatten and fully connected layers. And we after that we have to compile the model. And next one is evaluate the model. And finally we just ensure that model is working by displaying the visually through accuracy, model accuracy, loss, and so on. So here we have the image data set, and it will be worked. And finally the test accuracy will be the 72 percentage, and the loss will be 0.81. And we can through this visualization diagram we can able to know the model accuracy and model loss. And the next application is text classification using CNN. It will be used in the natural language processing. And we can have a text classification. This we can able to review the movies. And for that we can use IMDb review data set. So we have to load the data set first and pre-process the data. And pre-process the data, we have to fix the length. And we have to build the sequential model. And in this we can use 1D convolutional layer. And it will the convolution in this layer, it will convert the 1D into dense 100 dimensional vectors. And we can also use the global pooling. It will reduces the feature map into a single number. For that we can use the global pooling. And fully connected layer we can have. And compile the model here, we can use optimizer Adam, loss metrics. And finally we have to train the model by we giving the training data set and number of pages and batch size and validation data through X and Y dimension. And evaluate the data through X and Y test data. And finally we must know the test accuracy data. And this is the way we have to use. And finally you have to make a prediction on new text. So we have to use the tokenizer to consistent with the training data set. And after that we have to use the encoding of text into sequence. And finally we have to give an example of review whether the movie was absolutely wonderful or not. And we have to predict the statement. For that predict the statement, we can use the function predictor of encoded function. And it will give a positive prediction value, or if it is greater than zero point 0.5, otherwise it will shows negative feedback. So here we have downloaded the data set from the Keras data set IMDb PNPZ. And we have gone through the model. And finally we can have the test accuracy of the data set 88.60. And we can predict it the analysis whether it is positive, the confidence level is 1. Through this confusion matrix we can able to know the confidence level. So and the next one is the next application is CNN image generator using autoencoder. So in this autoencoder image generation, we can also use the image dataset that we can MNIST dataset. And same as we have to load uh, load the data set. So MNIST data set here. So here we can use a NumPy library. So for numerical operations and reshaping the arrays. And then we can use a MNIST data set. And we can also use the Keras model here. Keras model to build the CNN based autoencoder. And we can load the data set over the images of 60,000, I thought. So 60,000 images and 60,000 trained images and 10,000 test images. And as usual, we have to reshape the images into number of images or height and width. So based on that, we can reshape into 60,000 28 28 1. So reshape the images of 28 28 1. And after that you have to build the encoder model. So here we have a 2D that will extract the features of age curve stroke from the images. And we can also use the ReLU function here, max pooling ReLU function here. And max pooling 2D we have used, so it will reduces the image size by half, or it will be compressed. And after two convolutional layers, the image shape reduces into it reduces the size, that is 28 by 14, 14 by 7. And after this encoded layer, we have a compressed feature map. And the next one is decoder. So in this decoder, we have to take the input from the convolutional 2D layer, and we can use the upsampling 2D layer. It will reverse of the encoding. So it can expand the feature map back into the original size. So we have 28 to 14, 14 to 17. It can be reversed for 28 to 14, 14 to 7. So it will double the dimension. So inverse of the polling. So we used upsampling. And the next one is we have final convolutional, that is final convolutional we have. So it will produces the pixel values into zeros and ones. So after that we can have after the compilation of the particular model, and it can have the complete results. So we can have this model auto encoder, and finally we can compile the model, and we can reconstruct the images, and we must able to know the predicted images. And we can have adam classifier, that is adaptive learning rate optimizer. It will be used efficiently. And finally we can able to display the image with a number of parameters. So here we have. So it will generate or reconstruct the images. It will pass through all the input images through encoder and the decoder. So the output images, that will be the generated reconstructed image. It can be similar to the original only. It will display 10 original and 10 generated images for comparison. For example, both are same size, and we can show the digit images as in the grayscale only. So whatever the input we have given, it will be converted into grayscale image. This is the way we have to use image generation. Yes, yes, guys. Hope you all understood. Any doubt in this?
Thank you, ma'am. Thank you so much. Participants, do you have any queries? Okay, ma'am. May I conclude the session, ma'am?
Yes, ma'am.
Okay, thank you, ma'am.
Thank you all.
Once again, good evening, everyone. As we conclude today's session, we sincerely thank Dr. P. Geetha ma'am for her insightful guidance and all participants for their involvement. Your enthusiasm makes today learning engaging and productivity. We look forward to another exciting day tomorrow. Thank you, guys. Thank you all.
Thank you.
Thank you, ma'am.